All right, hey guys, so welcome back. We're going to continue to move along. We're jumping into 9.2 day 2. Our goal today is to talk about sectors, and a lot of what I'm going to talk about today hopefully will seem like review because you do know a lot of this from geometry. Give me a second. I'm going to try to block that glare. Hold on a second. Hold on. You're right there. That's a little better. Yeah. All right. So, sorry about that. Okay. So a sector is a region of a circle bounded by two radii and an arc of the circle. Think about a pizza slice. Okay. So if I'm looking at this circle, think about a pizza. Here's my slice of pizza. This is what we call a sector of the circle. All right. The central angle theta of the sector is an angle formed by two radii. So you see your two radii right here. They come together to form this angle theta. That's your central angle. So again, we have radii, radii. This right here is your arc. Your arc length is going to be S. Your central angle is theta. All right. If I want to know the area of this sector, and I'm working in degrees, I would use this formula, which you guys did learn in geometry. The area of the sector is equal to theta over 360. So it would be this angle over 360 times pi r squared. The theta over 360, that's going to give you the fractional part of the circle. All right, so for instance, if you were looking at, let's say, a 90-degree angle, just making the math easy, if it was a 90-degree angle, 90 over 360 is 1/4, okay? So this would simplify down to 1/4 because that would be 1/4 of the whole circle. And then you multiply by the area of the circle. S, meaning the arc length, if I want to know how long this arc length is, I first find the fractional part that this represents in relation to the whole circle. And then once I know the fractional part, I multiply by the circumference of the circle, 2 pi r. All right, now we have the equivalent equations in radian form. Notice instead of 360, I replace 360 with 2 pi. Because in the last lesson, we learned that 360 degrees is equivalent to 2 pi radian. Okay, so I just replace it with 2 pi, and then you're able to kind of simplify. The pi's actually cross simplify, which is why the equation becomes 1/2 r squared theta. All right, for arc length, again, just taking this formula and replacing 360 with 2 pi, and here the 2 pi's cancel, which leaves you with just radius, the radius times theta. Okay, so those are your formulas. All right, so let me erase and get the problem up here. We don't actually have a long lesson today. It will be a quick one. All right. So it says, I'm not going to write the entire word problem down. You can look in the notes. A softball field forms a sector with the dimensions shown. Okay, and I'll draw the diagram in a second. Find the length of the outfield fence and the area of the field. Okay, so the diagram that's in the notes looks like this. This is supposed to represent a baseball field. Okay, and what they want you to do is find the length of this arc. All right, so I want to know what is the length of this arc right here. All right, and then what is the area of the sector? And you are given that this is 180 feet, and this is 180 feet. Okay. All right, so we are going to work in degree form. So first, let's find the sector length. Okay, so S the sector length is going to be theta over 360 times 2 pi r. All right, because it's related to the circumference. So since this is a 90-degree angle, 90 over 360 equals 1/4, right? If I was to draw a full circle, this would be 1/4 of the full circle. And then you're going to multiply by 2 times pi times r. And again, if this was a full circle, your radius, and maybe I should have drawn it as a full circle, your radius will be 180, right? So you kind of have to view this as like a whole circle, and the radius is that 180. Right, so 1/4 times, well, 2 times 180 is 360, so I can kind of clean that up a little bit. All right, and then 360 divided by 4, and then you can leave pi for now. Oh, I forgot the square. Oh no, I'm sorry, I'm looking at the wrong thing. 360 divided by 4 will be the 90 pi. Sorry guys, looking at the wrong thing on my paper. 90 pi. And my units are feet. Okay. Now we're going to find the sector area. So the area of this sector in relation to the full circle. So that formula, area is equal to theta over 360 times pi r squared. So again, it's going to be 90 over 360. We're looking at 1/4 of the full circle. And then you have to multiply that by pi and your radius 180 squared. So 180 squared, this is where I was looking before and getting the wrong numbers. 180 squared is going to be 32,400. And then don't forget your pi. And then 32,400 divided by 4 is 8,100 pi, and it's feet squared. So those would be the exact answers. If the direction said to round to whatever place, then you would plug this into your calculator, multiply 90 by pi, 90 times 3.14, and get your decimal approximation. All right. Okay, let me erase and get set up for the next part. Okay, just one quick reminder that will help you with some of your homework. Distance formula. So the distance formula, finding the distance between 2 points, d equals the absolute value of the difference of the x's squared plus the difference of the y's squared. Okay, so that's just a quick reminder, which might help you with some of your homework problems. So just keep that in mind. Okay. All right. And then the last thing you're going to do, it's not going to be part of this video, but I will attach another video in Google Classroom. You're going to become familiar with your unit circle. Okay, so I will attach a video and I will attach a worksheet, but you are going to become familiar with your unit circle, and you're going to need to know some of the common angle measurements, the angle degree measurements, and what their equivalent radian measurements are. Now, we did learn how to convert, right? That was in the last lesson. So you can always convert from degree to radian by multiplying by your conversion factor, but it's often very helpful to just know some of these off the top of your head. Just like with multiplication, you know, multiplication is repeated addition. We could sit here and add, but it's a lot faster to know your multiplication facts. So make sure you watch the other video related to the unit circle and print out the unit circle worksheet that I'm providing for you and fill in the degree and radian measurements on that unit circle. And I'll talk more about that in the next lesson. Bye.